Okay, students, now we come to a tougher chapter topic. Mod 3, Topic 2, Lesson 1, Trigonometry. Okay, this is the most used chapter that you'll get out of geometry that you'll take on to Algebra 2, Pre-Calc, and Calculus. So you want to, those that plan on going higher and you want your math life to be easier, master this chapter. We've been doing special right triangles and radicals in our warm-ups all quarter long so far, and this is where you're going to come into play as well throughout this chapter. All right, so you're going to learn in this chapter reference angle, opposite side, adjacent side, and SOHCAHTOA that we'll get to at the end here. For a quick review, how many centimeters are a meter? Centimeters, centime is a hundredth, so there's 100 centimeters equals 1 meter. So how you'd write that relationship, showing it equal to the total of 1, you'd have 1 meter over 100 centimeters, and that would equal 1. Those are equal. Okay, so use a ratio you wrote in question 2 to convert 520. So you're dividing by 100. 520 divided by 100, which means move the decimal place 2 places to the left. So 5.2 meters. 520 centimeters equals 5.2 meters. Okay, uh, you're not doing any of this in this topic, but just talking about relationships and ratios that we've already been talking about. All right, so now we go to special right triangles that we've already talked about before. We're going to talk about it again. So in the past, we just told you the relationship around 45, 45, 90 was A, and A root 2. Okay, now we're going to see that that makes sense. Okay, so we know if this is 45 degrees right here, this has to be 45 degrees because those two angles are what to each other? They are complementary. Why do we know they're complementary? Because that's 90 degrees, and we know all three angles add to 180. So 180 minus that 90 degrees that's already there is 90. So those two angles add to 90, which means they are complementary. Two angles that add to 90 degrees. So now we have a 45, 45, 90, which means that's an isosceles right triangle. Another vocab. So whatever this side is, that side is. That's why it's A and A. And then, so how do we get A root 2? Where did that come from? Okay, well, we can use Pythagorean theorem. Okay, so say I don't know what that is, but I know that's A and A or X next, doesn't matter. Pythagorean theorem would say A squared plus A squared equals C squared, the hypotenuse. Remember, the hypotenuse is always across on the right angle side. Remember, we name side lengths with lowercase letters if we're going to use a single letter, or we could call it side BC and side AC and side AB. All right, which you've already seen from your warm-ups as well. So I have A squared plus A squared, that's 2A squared equals C squared. Remember, C squared being the hypotenuse. And so to solve for that C, I need to take the square root of both sides. So C equals square root of A squared is A, and I still have that radical 2 right there. Okay, so that's where A root 2 comes into play, and that's why it is right there. Okay, some of you will understand that, some of you won't, and you just accept it, A and A root 2. Okay, next, we're going to talk about vocab. Okay, when they put an arc right here, talking about that angle, that is called the reference angle, or that's the angle symbol. So everything now, calling the sides in relation to that angle right there. So remember, adjacent. Well, first off, you always name the hypotenuse first so you don't blow it. Hypotenuse is the longest side always crossing the 90-degree angle. So hypotenuse, name first. That's what 1ST first. So now my other two options are adjacent and opposite. We should know already from math all throughout the year, adjacent means next to. So this side is the one that's next to the reference angle. And of course, that side would be opposite. That's why it gets opposite, OPP for opposite. Now let's say we switch it and make this the reference angle. Again, we name the hypotenuse first, And now this side is next to the reference angle, so that's the adjacent side. And that side becomes the opposite side. So if you notice here, the hypotenuse does not change. Hypotenuse is always hypotenuse. But what can change is what side you call the opposite and which you call the adjacent, depending on where the reference angle is. So you need to be paying attention to that vocab. And so that's what they have down here. Okay, reference angle, going with the arc. Opposite, another word for opposite would be across from, but the vocab word you're going to use over and over is opposite, and then adjacent, meaning next to. And of course, as I say, it's not the hypotenuse because you always name the hypotenuse first. H for hypotenuse, O for opposite, and A for adjacent, just so you know. Okay. All right, now go to page 540. Okay, number 10 here. We already went through and showed why we had 45, 45, 90, x, and x root 2. We did the Pythagorean theorem to show that beforehand. I went ahead and did it in the earlier one, but could have done it here if I hadn't done it there already. Okay. Um, so notice this is the reference angle. It says determine each side of the length ratio. The opposite side. So again, if that's my reference angle, this is the opposite. That's the adjacent, and that's the hypotenuse. Remember, name the hypotenuse first, cross from the 90-degree angle, then we have opposite and adjacent. So the opposite side, notice the opposite side is x to the length of the hypotenuse, x root 2. So determine each side length ratio. Now we need to simplify that. The x's will cancel out, and I have 1 over root 2. Can I leave a radical in the denominator? No, so I rationalize it, as you've done in your warm-ups. So I get root 2 over 2. Okay, that would be the ratio of the opposite side to the hypotenuse. How about the adjacent side? Well, we should see the adjacent side is also x over the hypotenuse, x root 2. So again, that answer is going to come out to the same. We're not going to work it all out again. You just saw it there. So root 2 over root 2 is my final answer. And then lastly, opposite side to the adjacent, x over x. So that relationship is 1. 1 to 1, they're the same. All right, go to the next page. Now we have the 30, 60, 90 degree special right triangle. We've told you those were the relationships. So let's see if that makes sense with Pythagorean theorem. We know the 30-degree side is opposite the 30-degree angle. We know that 30-degree side is half the hypotenuse, so we double that to get the hypotenuse, 2x. And the 60-degree side opposite the 60-degree angle is root 3 times longer than the 30-degree side, x root 3. We've just told you that in the past. Now let's go ahead and prove it with Pythagorean theorem that those relationships can occur because it's a right triangle. So if it's a right triangle, that means the Pythagorean theorem must be true. So we have a squared, we'll just call that one x squared, plus x root 3 squared equals 2x quantity squared. Okay, a squared plus b squared equals c squared. Okay, that's just if I went ahead, oops, change the color, we'll call it A, B, and C for A, B, and C. Okay, so now we get x squared plus, we know root 3 times root 3 is 3, so that's 3x squared. And we know 2 times 2 is 4, and x times x is x squared. Is that true? Yes, 4x squared equals 4x squared. So that does make sense that those could be possible side lengths because it satisfies the Pythagorean theorem. Okay, so you can now you hopefully understand that these do make sense. They're just not just randomly thrown in there. Okay, now go ahead and go to page 545. This is already 541, so 4 pages. 1, 2, 3, 4. Okay, so we're going to go ahead and review and add in a little new pieces. So we're going to fill in these right here. If B is the opposite side, if that's the opposite side, that makes this the reference angle, right? So X is the reference angle. If y is the reference angle, so now we erase that. If y is the reference angle, so we put the reference angle there, then b is called the what side of that? Remember, that's the hypotenuse. This is the side next to it, so that's the adjacent side. And lastly, if x is the reference, so now we change it, make x the reference, then b is called the what? Opposite. OPP for opposite, or you can spell out opposite. All right. Next, what we have here, it says determine the side length ratios of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Using angle A as the reference. So they told me angle A is going to be the reference each time. Write your answers as fractions in lowest terms. Okay, so I'm going to introduce this acronym called SOHCAHTOA. You know, be able to spell that correctly from here on out. It gives you these three relationships. So S stands for sine. Okay, sine, which on your calculator, so we just use the first three letters. You don't pronounce it sin, it's sine, is the opposite O over the hypotenuse. So written out longhand, opposite over hypotenuse. See, sometimes written like that. So that's this first one. Cosine, if it asks for cosine, change the color. Cosine is spelled like this. And on your calculator, the first three letters, COS, equals, as it says here, adjacent over hypotenuse. So go a single letter, adjacent over hypotenuse, which equals adjacent over hypotenuse. That's the cosine. And lastly, we have tangent. And of course, the first three letters, which then are on your calculator, tan. The tangent is opposite over adjacent over A, or opposite over adjacent. Notice these are all fractions. So your answer is going to be as a fraction. That's why it says, write your answers as fractions in lowest terms. Okay? So they didn't bother to tell you that opposite over hypotenuse was the sine. They didn't say find sine, cosine, and tangent, but that's what really they're asking, to find the sine, the cosine, and the tangent. You're going to be introduced to those perhaps in the next lesson. Okay, I'm just telling you right now since they brought up these phrases. So you start learning this right now. SOHCAHTOA. All right, so what I'm going to do is I'm going to say sine equals opposite over hypotenuse. So first I'm going to label the hypotenuse, label the opposite across from, and the adjacent. And now I just fill it in. So the sine, opposite, 18 over 30. Reduce it. GCF is 6, and you get 3/5. Cosine equals adjacent over hypotenuse. The next one they ask is 24 over 30. GCF is 6, so you get 4/5. And the tangent is opposite over adjacent, which is 18 over 24. GCF is 6, and you get 3/4. Okay, so those would be our answers for the first one. Now we're just doing that again in the next ones. So I want you to pause the video and work out the others if you're doing this on your own, because you weren't here in class when I had you do it in class like this. And you do sine, cosine, and tangent for these ones right here, and check your answers. When you're done, hit play again, and I'll have the answers down for that. All right, 2. Let's move this up here. Sine. Opposite. Okay, so reference angle is A, so there's the opposite, there's adjacent, there's hypotenuse. Over H. 0.5 over 1.3. Remember, no decimals in a fraction, so we go ahead and multiply by 10, move it across 1, and I get 5/13. Cosine. Now I could go ahead and just multiply each of these by 10 right now to get rid of them. Okay, so I have 5, 12, and 13. Notice those are all natural numbers. That's a Pythagorean triple, 5, 12, 13. We'll talk about Pythagorean triples here soon. So cosine is adjacent over hypotenuse. The A, 12 over the hypotenuse, 13. And tangent is opposite over adjacent. I want you to write them down each time so you get memorizing these. Okay, obviously you can just look at SOHCAHTOA up there as well, but get a pound in your head because you use this year, algebra, pre-calc, calculus. Get this pounded in. Opposite 5 over the adjacent 12. So there's those answers. All right, free. Okay, so we have to first find this side. So you're going to use Pythagorean theorem unless you know your Pythagorean triples. Okay, for those that want to learn a shortcut on how to figure out your Pythagorean triples, I look for the GCF here, which is 3. And I divide each of these by 3, and I get 8. And divide by 3, and I get 17. And then a Pythagorean triple is 8, 15, 17. So I know that would have to be 15, but then I'm going the reverse direction. 8 times 3 gives me the 24, so 15 times 3 gives me a 45. And 17 times 3 gives me that 51. So I knew 8, 15, 17 was a Pythagorean triple. Otherwise, you have to do Pythagorean theorem, put in your calculator and all that kind of stuff. So that's how I calculate it in my head. Okay, so now I'm doing sine, cosine, and tangent again. I'm not going to keep writing out O over H. It's over H. So again, reference angle is A. So then that makes this the O, this the H, and this the A. So O, 8, and then once I have it reduced like that, 8, 17, because I have to reduce anyway, 8 over 17, opposite over hypotenuse. Cosine, adjacent over hypotenuse, would be 15 over 17. That's one thing if I have it reduced down to the Pythagorean triple. And then tangent, opposite 8 over adjacent 15. Okay, and here we have another one, 20, 21, 29. Happens to be a Pythagorean triple, otherwise I use Pythagorean theorem. A is the reference angle, hypotenuse, opposite, and adjacent. So I have sine is opposite, 21 over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, 21 over 20. None of those reduce. If they reduce, I have to reduce them. All right, last two. Let's go to the next page here. Okay, so now here, I want to see if I recognize any pattern in these two that they have. I should see that I have a 5 there and a 5 root 2. I should remember, oh yeah, there's an A, and A root 2. And there's that root 2 there, and that A is the same as that. So I should recognize that's a 45, 45, 90 special right triangle. So that means this also must be 5, 5, 5, and 5 root 2. And here, I should say, oh, this is half of that. Don't we have something that's half? We're going to have an A, and A root 3, and a 2A. The A is half of the 2A. So this was the 30-degree side, this is the 60-degree side, and this was the 90-degree side. So if A is 6, that's the 30-degree side. This is the 60-degree side. So the 60-degree side, I multiply by root 3. So I get 6 root 3. And then the 90-degree side, 2A. Okay. If you did not recognize that, you would have to use Pythagorean theorem. And in using Pythagorean theorem, you'd come up with those answers right there. Okay. So if you need to check it with Pythagorean theorem, you can go ahead and do that. All right, there we go for lesson 1.